Hi, welcome to The Measure of Things. This is the second video in a short introductory series for Ms. Moser's chemistry class. We're going to be talking about measurement. Measurement is critical to chemistry. We make a lot of measurements in chemistry. Things that we often measure are mass, volume, temperature, and density of substances that we're dealing with. All of these measurements that you make will give you numbers, which means what? It means that these are quantitative pieces of data. Quantitative data is concerned with numbers. It involves a numeric element. This is versus qualitative data, which is descriptive. If we say that we have 32 grams of sodium chloride, that is quantitative data. If we say that the sodium chloride is made up of small white crystals, that's qualitative data. When we talk about measurement, we're always talking about quantitative data. If we take this board as an example and we want to make some measurements, there are a number of things that we could measure. Just for starters, we could measure its density, its length, or its mass. These are all quantities. The quantity is the thing that's being measured, and it's different from the units that we use to describe those quantities. If we stick to the example of length, it would be sensible to measure this board in meters or centimeters. We can't measure the length of something in grams or seconds. If we wanted to measure the mass of the board, it would make sense to do it in grams or kilograms. We certainly couldn't measure the mass of something in degrees Celsius or in feet or gallons. Now, if we want to measure the density of the board, this gets a little bit trickier. Can we measure the density of the board in meters? No. Or grams? No. We have to measure the density of the board in a different kind of unit. We'll save that and come back to it. You probably already know this from physical science, but in science, such as chemistry, we use the SI system, the System International, to take all of our measurements. There are 4 standard SI units that we'll use a lot in chemistry. We'll use the kilogram, whose abbreviation is kg, and that's used to measure the quantity mass. So kilograms is the SI unit for measuring mass. If we have to measure the length of something, we'll measure it in meters or some derivative unit of meters. Meters is abbreviated with a lowercase m, and the quantity that meters measures is length. So meters is the SI unit which measures the quantity length. We can measure temperature, and the correct SI unit for measuring the quantity of temperature is degrees Kelvin or kelvins. That's abbreviated with a capital K. So kelvins are the units used to measure the quantity temperature. And the last SI unit that we use extensively in chemistry is the mole. Not the furry kind. The mole is the SI unit that's used to measure the amount of a substance. So there you have it. Those are the 4 SI units that we use extensively in chemistry to measure the quantities of mass, length, temperature, and amount of a substance. Now let's talk a little bit about what are called derived units. So, remember when we talked about our board? We were able to measure its length and its mass using standard SI units, but we said we couldn't measure density the same way. There are a lot of things about this board we can't measure the same way. Its area. Can you measure the area of the surface area of this board in meters? No, because you have to multiply the length times the width, which would give you meters squared. What about its volume? Volume is obtained by multiplying the length by the height by the width. If you pay attention to your units, that would give you meters cubed. These are derived units because they're made up of combinations of SI units. There's not just 1 meter here, there is a meter times a meter. There's not just 1 meter here, there's 1 meter times 1 meter times 1 meter. These are some simple derived units. Let's talk about density. Density, as you may remember, is the mass of an object divided by its volume, or the mass per unit volume. Well, what are the units that we use for mass? Typically, in the SI system, kilograms. What are the units that we use for volume? Meters cubed. So something like density is measured in kilograms per meter cubed. You use derived units every day. When you talk about the speed of a car or anything else, miles per hour is a derived unit. Of course, in SI, we'd say meters per second. Okay, so let's review. The SI units that we commonly use in chemistry are the kilogram, the meter, the Kelvin, and the mole. Now, let's look at our derived units that are commonly used. The cubic meter and the kilogram per cubic meter are common derived units that we use often in chemistry. Now, let's quiz. Which one of these things is used to measure the amount of a substance? Ready? That's right, the mole is used to measure the amount of a substance. Now, which one of these units would you use if you were measuring the mass of an object or a substance? Are you ready? That's right, the kilogram is what we use to measure the mass of a substance. Which unit would you use if you were measuring the volume of a substance or an object? Go ahead, write it down. That's right, we'd use the cubic meter to measure the volume of an object or a substance. Now, we talked about the rest of these back in the video. You can review them on your own. But let's talk about a matter of practical concern as we measure things in chemistry. When we're measuring the volume of liquids, as we commonly do in the chemistry lab, we're usually working with pretty small amounts. 1 cubic meter of liquid is probably about what your bathtub holds. Those would be crazy numbers to work with for something equivalent to what you might have in a drinking glass. As you know, the SI system is easy to work with because you can convert larger and smaller numbers using a series of prefixes. Though the SI derived unit for volume is the cubic centimeter, or the cubic meter, we more often use the cubic centimeter. It's a much smaller and easier to work with unit for our purposes. So, the cubic centimeter is what we usually use. Something you should know. You've all heard of liters because you know what a 2-liter bottle of pop looks like. In chemistry, we do often use liters to measure things, and we very commonly use the milliliter, 1/1000th of a liter. Now, 1 milliliter is equal to 1 cubic centimeter. That's a handy little conversion that you'll want to keep in mind. You'll use it a lot this year. 1 milliliter equals 1 cubic centimeter. So when we measure the volume of liquids in chemistry, though we could use a cubic meter, we more often use cubic centimeters or milliliters, or if we have a larger quantity of something, we may use liters as well. Okay. We have one last concept to cover before you're done with your second video. If I give you a container of a liquid and I ask you to measure its volume, you can do this using a variety of tools, and there are 2 things that are important to note about your measurement. The first is its accuracy. Its accuracy is how correct your measurement is. If I know with great certainty that I gave you 1 liter of liquid, and you measure it and tell me that there are only 0.75 liters of liquid there, your measurement is not very accurate. It's not very close to the true value. So that's accuracy, how close the measurement is to the true value that's known. There's one other thing that we have to be concerned with measurements that you make. That's the precision with which you make the measurement. Precision has a lot to do with the instrument that you're using to make the measurement. Precision is about how reliably a measurement can be reproduced. If I give you that same liter of water, and I know that there's exactly 1 liter of water, and you measure it the first time and tell me there are 0.75 liters of water, and the second time you measure it, you tell me there are 1.25 liters of water, and the third time you measure it, you tell me that there are 1.5 liters of water, your measurements are all over the board. You obviously can't reliably reproduce your own measurement. Your measurements lack precision. Now, if I know that there's 1 liter of water exactly, and you measure it and tell me the first time that there's 0.75 liters of water, and you measure it 5 more times, and each time you come back with the same answer, yep, 0.75 liters of water, your measurement is precise, but it's not accurate. The goal in all of our measurements in the chem lab is to make our measurements both accurate and precise. That is, close to the true value or correct, but also measurements that we can reliably reproduce again and again and again. Okay, that's it for this segment, the measure of things. Now, if you'd be so kind as to return to the PB Works Chemistry Daily page, follow the link, and take your follow-up quiz. Thanks again.